In this video, we will now look at the second type of standard graphs in the H2 syllabus. This family of curves is known as the conic functions. This class of curves are called conic functions because they are derived from a pair of cones. Now, imagine if I have a pair of cones and I take a knife and slice it parallel to the base. What we end up with is a cross-section that is a circle. Next, if we tilt the knife slightly such that it is less thick than the slant of the cone, like this, what we will end up with is an elongated circle or an ellipse. If we tilt the knife even more such that it is steeper than the slant of the cones or even vertical, what we end up with is a pair of curves that look like this. These are what we call hyperbola curves. Also, if we cut the cones parallel to the slant of the cones like this, what we end up with is a family of curves called the parabola. And by now you should be very familiar with parabolas because all quadratic graphs like y equals x squared are parabolas, and thus we will not be covering parabolas in this video. All four types of these curves can be represented by an equation that contains quadratic terms of x and y. And we can perform completing the square to transform the equations into this following form, which is more useful for us in determining the characteristics of the graph and hence sketching the graphs. For the circle, the standard equation can be represented in the form of x minus h squared plus y minus k squared equals to r squared, where the point with coordinates of h, k is the center of the circle and it has a radius of r. And with these two pieces of information, we can draw the curve to look like this circle over here. In this example, we are asked to sketch the graph of x minus 3 square plus y minus 4 square equals to 25, and 25 can be written as 5 square. And thus, we can see that this is exactly the form of x minus h square plus y minus k square equals to r square, where h is equals to 3, k is equals to 4, and r is equals to 5. And therefore, we know that the center of the circle is at the point 3, 4, which is somewhere over here, and the radius is 5. And note that if we perform Pythagoras theorem for 3 square plus 4 square, we will end up with 5. And this means that from the center of the circle, if we draw a 5-unit circle, it will touch and pass through the origin, and therefore the graph will look like this. The standard equation of an ellipse takes the form of x minus h squared over a squared plus y minus k squared over b squared equals to 1. If we let a equals to b, what happens is that we can manipulate this equation such that it becomes x minus h squared plus y minus k squared equals to a squared, which is the equation of a circle that we have just learned. This shows that the circle is just a special case of an ellipse when the two denominators are equal. In this equation of the ellipse, the point hk takes the same meaning as the circle. It is the center of the ellipse. A represents the horizontal radius of the ellipse, and B represents the vertical radius of the ellipse. So graphically, the ellipse looks like this. In example 2, we are asked to sketch the graph of x minus 3 square plus 4 times of y minus 4 square equals to 16. Note that the coefficient of x square and y square are going to be different now because of the 4 over here. And therefore, we have to transform the equation such that the right-hand side becomes a 1. How we can do so is to simply divide throughout by 16, which gives us x minus 3 square over 16, which becomes 4 square, plus y minus 4 square over 4, which becomes 2 square, equals to 1. And therefore, with this, we know that the center of the ellipse is at 3, 4, which is somewhere here. The horizontal radius of the graph is 4. That means is going to end up at -1 and 7. The vertical radius is 2, therefore we will end up with 2 and 6. And therefore, with these 4 points, we can connect the dots to form the ellipse like this. Finally, for hyperbolas, there are 2 forms that it can assume. We shall call them type 1 and type 2 for simplicity. Type 1 takes this form of equation, x minus h squared over a squared minus y minus k squared over b squared equals to 1, which is very similar to the equation of the ellipse, except for this minus sign over here. The graph of type 1 hyperbolas take this shape. One way you can remember it is that since the coefficient of x squared is positive, the graph will take an x shape where x is written in a cursive manner like this. Type 2 hyperbolas have a very similar equation form, except that the minus sign is now in front of x squared rather than in front of y squared. And the graph will be in the other 2 quadrants as compared to the type 1 hyperbolas. So as long as you can remember how type 1 graphs look like, you will know how type 2 graphs will look like. Let us now take a look at the characteristics of both types of hyperbolas. For type 1 hyperbolas, the information that we can obtain from the equations are: number 1, the intersection of the 2 asymptotes is at the point h, k. You can consider this as the center of the graph. Number 2, the gradients of the asymptotes are plus minus b over a. And with these 2 pieces of information, we can determine the equations of the asymptotes using this equation. Number 3, the denominator a is the horizontal distance from the center of the graph to the vertex of the graph. With these informations given, it is sufficient for us to sketch the shape of type 1 hyperbola. Of course, we still have to find the coordinates of any intersections with the axis by substituting x equals to 0 and y equals to 0. Type 2 hyperbolas have very similar characteristics as type 1 hyperbola. The intersection of the asymptotes is still located at h, k. The gradients of the asymptotes are still plus minus b over a. The equation of the asymptotes can still be found using the same equation. The only difference is that now the denominator a no longer has any meaning, but instead b represents the vertical distance from the center to the vertex of the graph. Thus, the graph of the type 2 hyperbola looks like this. In example 3, we are asked to sketch the graph of x minus 3 square minus 4 y minus 4 square equals to 16. Now if we divide throughout by 16, we will end up with the equation of x minus 3 square over 4 square minus y minus 4 square over 2 square equals to 1. So we know that the gradient of the asymptotes will be plus minus 2 over 4, which becomes plus minus half. And therefore, the equation of the asymptotes will be y minus 4 equals to half multiplied by x minus 3, which can be simplified into y equals to half x plus 5 over 2. And the other asymptote will be y minus 4 equals to negative half x minus 3, which can be simplified into y equals to negative half x plus 11 over 2. And also, we know that this is a type 1 hyperbola. That means we need to look at the horizontal distance from the center to the vertex, which is 4. And with all this information, we can then proceed to sketch the graph. So first, let's put in the axis. Next, identify the center of the graph at 3, 4. This is the point where your 2 asymptotes will cut across. Next, we can draw the 2 asymptotes like this and like this. And finally, we know that a is equals to 4. That means the vertex is going to be 4 units away from the center of the graph, which is going to be here and somewhere here. And therefore, with this, we can sketch the graph to look like this and like this.